Hi everyone. In this lecture video we are going to study some more problems related to Fourier series. So the question here is, obtain the Fourier series of the function f of x is equal to pi minus x by 2 in the interval. You can see the interval is an open interval for the limit 0 to 2 pi. Once you have found the Fourier series, you need to find its deduction. That is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on is equal to pi by 4. To start the solution in Fourier series, it is mandatory to check whether the given function is an even or odd function based on the given interval. So here given the function f of x is equal to pi minus x divided by 2 and the interval is a open interval for 0 to 2 pi. To check whether the function is even or odd, we have two limits. One is of the form 0 to 2l and the other is of the form minus l to l. These are the two standard intervals we have. So when it is 0 to 2l of this type, you have to replace x by 2l minus x. If you have an interval of this form minus L to L, then you have to replace x by minus x. Since our given interval is of first type, so I am going to replace x by 2L minus x. So for that you should know what is L. So given interval is 0, 2 pi, right? You can compare this with 0, 2L. So 0 is equal to 0. 2 pi is equal to 2L. 2 and 2 cancels out. So the value of L is equal to pi. So once we got the value of L, then use this 0 to 2L concept. If suppose I have the interval 0 to 2L, then in function replace x by 2L minus x. But our interval is 0, 2 pi. So I am going to replace x by, instead of 2L minus x, we have 2 pi minus x. So when we replace the function x by 2 pi minus x, if you get back the function, what is our function? Pi minus x by 2. If you get back this function without any sign change, then we say it is an even function. If you get negative of the function, we say odd. If it is an even function, find only a0 and an. bn will be 0. Why? Because bn is an odd term. If you find a function to be an odd, then you have to just find bn. a0 and an will be 0 as they are even functions. So we are going to substitute x has 2 pi minus x in the function. What is the function given? Pi minus x by 2. So when I replace x by 2 pi minus x, I have to replace wherever x is there 2 pi minus x. So it's pi minus 2 pi minus x whole divided by 2. So it is pi minus 2 pi plus x whole divided by 2. Pi minus 2 pi is minus pi plus x whole divided by 2. I can also represent this by taking a negative sign outside. So it is pi minus x whole divided by 2. You can see this term is nothing but the given function. So f of 2 pi minus x, I have got it has minus f of x because this is minus of the given function. So when you get f of 2 pi minus x is minus f of x. See the condition, f of 2 pi minus x is minus the function, then we say it is an odd function. If it is an odd function, just find bn. You can directly state a0 will be 0 and an will be 0. Even if you find by the neither even nor concept formula, you will get the answer 0, but you don't have to do it because we have already checked the condition is an odd. So since the function is an odd, what you have to do, you have to just find Bn. Before that, write the Fourier series. So standard form of Fourier series was a0 by 2 summation n is equal. So I have written the expanded form of Fourier series. This is a generalized form for the interval c, c plus 2l. But our interval is, it's open interval of the form 0, 2 pi, and we already identified L value as pi. And we check the function is an odd function. So since we have identified the function is odd, you can write a0 0, an 0, write the Fourier series only for Bn. Okay. So what happens to f of x? This term will be 0, this term will be 0, you don't have to write. It is only the sine function because it is an odd. Sine is always in odd function. Here the L value is pi, so I am just replacing it. So you have got f of x as 1 to infinity Bn sine nx. So this is the Fourier series which will take it as equation star. So here I have to find only Bn to get the series. Whenever we segregate a function as even and odd, Bn according to Euler's formula, Bn becomes 2 by L, 0 to L, f of x sine n pi x by L into dx. Whenever you say it is an even or odd, the formula differs. So here L value is pi, so Bn will be 2 by pi integral 0 to pi f of x. When I replace L by pi, pi cancels out, you will get sine nx. Whatever Bn is having in Fourier series, the same term will only exist in the integration as well. So to get Fourier series, what we have to find? Bn. So Bn we know it is 2 by pi 0 to pi. What is the function given in the question? Pi minus x by 2 was our function into sine nx dx. You can see x is here also and x term is here also. So you have to apply integration by parts. As I explained in my last video, you can apply Bernoulli's rule also. So I have stated the Bernoulli's condition here. Whenever you have product of function, take first function as a polynomial u. Second function can be continuous function. So it's a rule of integral and derivative. So u integral v minus u dash double integral v plus u double dash, that is 2 times differentiation and 3 times you are integrating. Alternate plus and minus for the entire series. So in this problem you can take u as the first term and v as the second term. Remember, u goes for differentiation and v goes for integration. So cross verify the terms here. It is u into integral v. So u I will write it directly. We have taken sine, integration of sine. So integration of sine becomes cos nx, that is minus cos nx divided by n. Next I have to take minus sign. Differentiation of u. What is u? Is this term. One time you have to differentiate. I have written this term here. No, differentiate this once. Pi is constant, it becomes 0 on differentiation, minus x becomes minus 1 by 2. Next I have to integrate 2 times v. Already you can see this term is one time integration, right? You integrate this one more time including sine, do not take sine outside. So integration of cos, we know it is sine nx by, already you have n, on integration one more n will come, right? Plus u is here, first derivative of u is a constant, next derivative will become 0. The integration process stops here. Directly take the limit 0 to pi. So you have to apply the upper limit x by pi and lower limit by 0. Before that, please remember sine 0 is 0, cos 0 is 1, sine n pi will always be 0, cos n pi will be minus 1 per n. So here I have applied the upper limit and lower limit. pi minus x. X is pi, so pi minus pi, this becomes 0 because pi minus pi becomes 0. Again, sin n pi. What is sin n pi from here? It is 0. So the first term is completely 0. Minus lower limit, wherever x is there you replace it by 0. Pi minus 0 by 2. So I can write it as pi by 2. First term is 0. So 0 minus, I have pi by 2 here, minus cos 0. What is cos 0? It is 1. So it is minus 1 by n because cos 0 is 1 minus sin 0 0. So it is 0. So we are left out Bn is equal to 2 by pi minus of minus plus pi by 2n. So 2 and 2 cancels out, pi and pi cancels out. So Bn is equal to 1 by n. So this value of Bn, please substitute in equation star, that is a Fourier series, summation 1 to infinity Bn sin nx. In place of Bn, we have to replace by 1 by n. Then suitable value of x has to be taken based on your interval to find its deduction. So Bn value is 1 by n, which I will be substituting in equation star. So the Fourier series, the required Fourier series for the function f of x is summation n is equal to 1 to infinity. Instead of Bn, you write it as 1 by n into sin nx. This is the required Fourier series. Okay. Using this, by suitable substitution of x, we can find its deduction. So let us go for deduction. So we need to deduce this Fourier series as 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and goes on up to pi by 4. We need to deduce it. For the deduction, as I already stated, you have to check whether the function Fourier series, whatever you have got, whether it's an even or odd function. Here you have got sine term, so it is an odd term, right? And your interval is an open interval. If it is an open interval, you know you cannot use the end values because the end values will not be considered when it is an open interval. So you have to choose the values between the 0 and 2 pi. Between the value 0 and 2 pi, you need to choose the x value. So between 0 and 2 pi, if you take a number line 0, I can take pi by 2, pi, 3 pi by 2, 2 pi, right? As I always told, don't take this kind of fractional. You cannot take 0 because sine 0 is 0, so this also cannot be possible. You cannot take pi because sine n pi is 0, sine 2 pi is also 0. So only possible you can take is x is equal to pi by 2. So once you have identified which value you are going to choose, kindly substitute this back to the Fourier series on both LHS and RHS. So f of pi by 2, I am replacing wherever x is there has pi by 2. So it is 1 by n sine n pi by 2. We know f of x is given as pi minus x by 2, right? In place of x, you replace it as pi by 2. So it is pi minus pi by 2 whole divided by 2. So f of pi by 2 will be, you can take the LCM for the numerator. So it becomes 2 pi minus pi by 2 into 2, which is pi by 4. This you can substitute it here. So it is pi by 4. Expand the summation when n is equal to 1 to few terms. So on the RHS, I am replacing n by 1, 2, 3. So it is 1 by 1 sine n pi by 2. N is 1, so it is pi by 2. Next put n is equal to 2, 1 by 2 sine 2 pi by 2. So I can cancel this 2 and 2. Put n is equal to 3, 1 by 3 sine 3 pi by 2, which exist. N is 4, sine 4 pi by 2 is 2 pi, right? So we have pi by 4 is equal to sine pi by 2. We know sine pi by 2 is 1, so it exists. Sine pi will always be 0. Then 1 by 3, sine 3 pi by 2 is negative 1. And sine 2 pi will always be 0. So you can see all odd terms of n are existing, even terms are becoming 0. So the next will be plus 1 by 5 Okay, next term will be minus 1 by 7 plus 1 by 9 minus 1 by 11, and it keeps on going. So we have got the deduction. Pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 minus 1 by 11. So this is how you have to proceed a Fourier series. The key notes are, please identify whether the function is even or odd based on the interval. Once you have done, you will be able to check whether it is, you have to eliminate a naught an or you have to eliminate bn. Once you have got Fourier series, identify the whether intervals are open or closed. Right? Based on that, you can go for substitution. Thanks for watching. Meet you in the next video. Bye.